Hello, and thank you for joining us today for the HPCC Systems Tech Talks. These are community tech talks from the HPCC Systems community for the HPCC Systems community, and we're glad that you're able to join us today. So please share. While you're here, please let others know that you're here with us. Use the hashtag HPCC Systems Tech Talks. Also, ask questions. We will answer as many of these questions as we can following each speaker. Also, we'll have polls throughout the presentation, so please look for the polls at the bottom of your screen, and if for some reason you don't see them, please exit the full screen mode or refresh your screen and you should see them then. And also, we welcome your feedback. Please do rate us, and if you'd like to be one of our speakers or if you have feedback for us, please reach out to us at techtalks@hpccsystems.com. So as we get started today, we're going to have our community announcements, and I get the honor of doing that today. So we get to talk a little bit about the HPCC Systems Community Day, which is happening here in Atlanta. Our registration is going to be open through September 21st for in-person attendance. And we hope that if you can't be here in person with us, that you'll join us online. We've got a live stream, and you can follow us throughout the day. We will have our workshops. We've got 2 wonderful workshops happening on Monday, October 8th, and we'll be also having a poster competition. So from some of our academic participants, they'll be bringing posters, and it's always one of the top draws on Monday, October 8th. On October 9th, we're going to have our main sessions, and that's the part that's live streamed, and we hope that you'll be joining us. We also have several breakouts this year, so you'll be able to follow along on the topics that are of interest to you. We also want to thank our sponsors. So we've got Cognizant coming in as a platinum sponsor. We've got Dell EMC and Infosys as gold sponsors, and we've got Datum coming in as a bronze. And we've got a silver sponsor coming up soon, so look out for that on our website coming up. And you can visit our website at hpccsystems.com/HPCC Summit 2018. All right. Oh, here's more detail on our workshops. So with the morning workshop, we've got a great lineup with Bob Foreman and Richard Taylor, who do so much of our training, and they'll be talking about data extraction and transformation with ECL. That will be a wonderful, good foundational workshop. We hope that you can join us for that. And in the afternoon, Arjuna Chawla and Dan Camper are going to be taking us a little bit deeper with a real-world data problem, and also some easy ECL solutions for that problem, and it's looking at New York City taxi data. So that will be a really good hands-on workshop for people to come in and look at those code examples and just really actually put to practice their ECL learning that they may have learned in the morning. Here's the agenda. You can follow this online, and it's continually being updated as we know more. But if you go out to our website, you can find the information on there. You can also find out more information about the live stream and how you can follow along with us remotely. So at this point, I'd like to turn our presentation over to today's guest moderator, which is Lorraine Chapman. And Lorraine is just one of my most favorite people. She's a consulting business analyst and internship program manager. So she has worked hand in hand deeply with each one of our interns and their mentors throughout the summer. So Lorraine, we're thrilled to have you today to help introduce each one of our interns and the topics that they'll be speaking about. So Lorraine, over to you.
Thank you, Jessica, for my introduction. I'm just going to forward this slide on so we can look at the first two speakers. Here we go. So we had a tech talk just around a month ago, and if you attended that tech talk, you will know that we've had 8 interns join us this summer. And at the last tech talk, we had 4 students present about their project. And this time we have 3 more of our students who will also be presenting about the work they've been doing as an HPCC systems intern this summer. So all three students presenting today are speaking about machine learning related projects, and they are all PhD students studying computer science. So Farah Al-Sharik is from Clemson University, and this summer she was mentored by one of our LexisNexis colleagues, Kevin Wilmoth, alongside her university professor, Dr. Amy Apon. And Sukaina Filali is from Georgia State University. Sukaina's mentor was Roger Dev, and he manages the HPCC Systems Machine Learning Library. Sukaina's project provided the opportunity to collaborate with one of our community users, DataSeers. And our final speakers today, taking a joint effort on showing Lily Ju's results from her project, and Gus Rayner is also joining us, one of our LexisNexis colleagues. Lily is also from Clemson University. Lily was mentored this summer by Arjuna Chawla, and together Lily and Gus are going to show how Lily's machine learning algorithm may be used to solve real-world problems using motor vehicle records. So our first speaker today is Farah Al-Sharik. Farah's project aim was to implement equivalence terms for our text search bundle. And given that I am not an expert in machine learning, I'm not a data scientist, I asked for a layperson's description about Farah's project and was presented with the following question. How similar does a term in a search request need to be to a term in the document to be considered a term match? And there are many challenges involved in considering the many language variants, including matching plurals and singular forms, punctuation, initialization, acronyms, etc., all related to solving this problem. Anyway, Farah is going to do a much better job of explaining all of this in her presentation, so without further ado, I'm going to hand over to Farah.
Good morning, everyone. I am Farah Shanik. I'm a PhD student in Clemson University, and now I'm working with Dr. Amy Apon. And my interest is focused on how to apply the high-performance computing to machine learning problems. Today, I will talk about the equivalence terms of the text search bundle. But before we start, I want to ask you a quick question. Are you familiar with the movie features? Please select the answer, and the result will be shared at the end of the presentation. So today we will talk about the equivalence term of the text search bundle, and there are different types that we want to talk about, which is the initialism, the abbreviation, the synonyms by using the movie features, and the similarity based on the context and how we can handle that using the word-to-vec algorithm. At first, what is the text search? The text search bundle is an open source project from LexisNexis that supports the searching for XML documents. Last spring, I've worked with 4 undergrad students with Dr. Apon and John Holt to improve some features in this project, and I've extended this work to include the equivalence term by working with Kevin and Roger last summer. So the equivalence terms are an essential capability for the text search because it's improve the performance of any text search engine or any text search tool. So in order to do that and improve the performance, there are many types or forms of the equivalence terms to be considered. As I said or mentioned before, the initialism, the state name abbreviation, the synonyms, and the similarity based on the context. First, the initialism or the equivalence of the initialism and the abbreviation. The initialism and the abbreviation can be defined as a word or a phrase that represent the whole term. For example, if we have the term U.S., which is an initialism for the United States, or if we have the term CA, which is an abbreviation of California. So the text can contain either the initialism with punctuation or without punctuation. So any search tool or any search engine using any form should define the string either with punctuation or without when we handle the initialism problem. So here if we can see in the list of the screen that we have the term u.s in the text or in the data set that we use for searching. And how we handle that, in the other screen, we see that we've added a new entries for each letter in this term without the punctuation. So here, the text search will be able to return the set of the documents that contain the term with or without the punctuation, any initialism term. Here we can see an example of the state name abbreviation. So if the user uses any search query that uses either the California or CA, which is an abbreviation of the California state, we are able to return the set of documents that contain any form of these terms. Now, the equivalence of the synonyms. The synonyms can be defined as two words or a phrase mean the same thing in the same language. So the text search must be able to return not only the document that contains the target word, but also return all the documents that contain the synonyms for this word in the search query. In order to do that, we use some data set called the movie thesaurus, which is an open source dataset that contains around 30,000 root words with 2.5 million synonyms. Here we see that how we link the movie thesaurus with the text search bundle by build a dataset for the term and related it to the set of the synonyms for the term. And here an example of the set of the synonyms for the target word or the term Abaddon. The equivalence based on the similarity of the context or on the context. We use some algorithm called word-to-vec. The word-to-vec is as a quick summary for the word-to-vec algorithm. It takes as an input a large corpus of the text and produce a vector space of several hundred dimensions, with each unique word in the corpus being assigned with a corresponding vector in the space. So the word vectors are positioned in the vector space such that the words that share the common context in the corpus are located in close proximity to one another in the space. So here the word-to-vec algorithm used in the text search bundle to find the similar words of the search query that share the common context in the corpus. Here we have an example for the search query, which is the school, and we see here how we return the set of the terms that are share the common context for the school. Not only the synonyms for the school, we can see that we have the teachers, the classes, the students, which share the same context with the school. And here we see that we have a full query, a full text search query, which is the students in school, and we see that each term in this query related with the set of words that share the common context. So, as the result of using the word-to-vec, we see how we return the set of documents that that have either the terms in the search query or the words that share the same meaning for the text search query for the previous search query, which is the students in the school. I have another question. Will this new text search bundle be useful in your work? Please select the answer.
Okay, wonderful. So This is a very fast presentation, so you may not have had a moment to get your questions in. But for the audience, go ahead and take a moment. If you have questions that you'd like to bring forth, we would love to see those, and we'd love to answer those. And so while you're doing that, and to give Farah an opportunity to go in and prioritize the questions, we've got a quick review of the first poll. So the first poll was, are you familiar with the Moby thesaurus? And 90% of you say that you weren't familiar. So hopefully, you know, if you answer this second poll question, hopefully you have found something that you can use in your work coming up. All right, perfect. So with that, we're going to go ahead and take a quick peek at our questions from the audience. So here's one. Will the use of Word2Vec replace traditional search engines?
In my opinion, the Word2Vec will not replace the traditional search engine, but it will improve the performance of the text search engine.
And would you be able to elaborate a little bit more on how this might improve the text search? Looks like that's another question that came in.
Yeah, okay. We see that when we use the Word2Vec, we will return the set of the words that share the common that have the same meaning. Not only the synonyms of the text, but it's share the same context. So when we see the query school, it's we have the students, which is not synonyms of the school, but it's related to the school. So by using this Word2Vec, the performance of the search engine will be improved.
Oh, very good. Thank you so much.
Mm-hmm.
All right. So I'm going to go ahead and look at the results of your second poll question. And that question was, would this new text search bundle be useful in your work? And it looks like 36%, so almost a third there, a little over, say that it would be useful. So that's good to know. And especially considering that 90% hadn't heard of it, that's positive. And 63% say that they're not sure, so the other two-thirds. But no one said no, so that's good. Hopefully everyone has something new to consider that will help them in their future. All right.
Mm-hmm.
Sarah, thank you so much. We appreciate
Mm-hmm.
you taking the time to come and present with us today.
Yeah.
And I'm going to turn it back over to Lorraine so that she can introduce our next presenter.
Okay, so as I said, all of these presenters are presenting about machine learning related projects, and we all know how machine learning is used a lot in all manners of different areas for getting results from data in real-world scenarios. And Sukaina's intern project is definitely going to demonstrate to us today how this can be. Her project may be used in a real-world situation to detect fraud. And she worked on this project in collaboration with DataSeers, one of our community users. And I'm really looking forward to hearing Sukaina tell us about this very interesting project, which looks at problems that are extremely relevant in today's world. So over to you, Sukaina.
All right. So good morning, everyone. Good morning, audience. My name is Sukaina Filali. I'm about to enter my fourth year in the PhD program at Georgia State University. I am part of the data mining lab at GSU, and my main focus and research interest is on time series data mining from the classification and clustering perspective. So in this summer, I worked on a project in collaboration with DataSeers, which is one of the community users of the HPCC system. The project name is fraud detection using transactional data from a time series mining approach. So before we start, I would like to ask the audience a question, which is more of a concern to a fine tech business to you. and I will follow up with the agenda of my presentation today. So I'll start with talking about data seers and their business in general. We're then going to dig into project specifics, which is the fraud detection project that we're talking about. We're going to talk briefly about our methodology as well as different features that we used in our model to approach the problem. And then I will show you a visualization at the end of the feature space that we engineered for this problem. So before we start, let's talk a little bit about who is Data Seers. So Data Seers is a company directed by Advait Joshi. It is based in Alpharetta, and it provides data ingestion and analysis solution for fintech or companies. So their technology is based on the HPCC system, and therefore it is massively parallel, and it comes with fault tolerance and full encryption. Their system architecture, as you can see from the figure below, it consists of various tiers that oversees, and they predict problems in the data before they even happen. So reading from left to right, the file series is fed data from different operational sources in the form of either structured and unstructured or hybrid data, and it then digests it into the HPCC distributed file system that you can see in the middle, which is well suited for data-intensive computing. So the four other different Seers modules in the right-hand side, namely the compliance Seer, recon Seer, fraud Seer, strata Seer, they can access the data from the distributed system for data processing and analysis purposes. And in this talk, or in this project, I should say, we worked on the fraud Seer module, which is a hybrid between a fraud engine that uses both the traditional rules and machine learning models to flag the undetected fraud in daily data. So the goal of this module is to spot undetected fraud and predict fraudulent behaviors before it happens. Yeah. So now we're going to talk about project specifics, and I'll describe the problem that we are addressing. So the problem that we addressed is the detection of fraudulent accounts or cards based on their credit and debit transactional history within a well-defined period of time span. So accounts that we worked with, they can come from different programs, and each program has different fraud risks associated with it. So I can give an example. For example, one of the riskiest programs can reach up to 1/3 of all the accounts being fraudulent. And the second goal of this project, which is at this point a future work, is to be able to predict the weekly burn down per program in terms of cash, and all that is for the purpose of a better cash management in the future. So there are in fact many fraud categories that are taking place within those programs, and among them is the money laundering fraud. I will just go over some examples of those frauds. So the money laundering can be defined as a high cash inflow or outflow in transaction amounts, or money that is transferred in high frequency from one card to another. The second category of frauds are suspicious activities with respect to the categories of vendors that we have. So we can have different, we can have suspicious amounts with regards to the merchants that the cardholders are using. Some other problems are inconsistencies with regards to the location of the vendors, as well as the name of those vendors. So there are some suspicious activities with regards either to the transaction by themselves or inconsistencies. Another example of fraud is a human trafficking case. So typically transactions are taking place within similar places and during one specific time of the day. Vendor frauds are card initiating a transaction with a fraudulent merchant, for example. And now we'll move on to talk about the data sources that we had available, that we worked with in this project. And as you can see from the slides, we had access to 3 different sources of data. The first one, data source that we use are time series data. So these are raw time series that captures daily balance amounts stored in the cards for different span periods of time. So it consists of daily debits and credit transactional amounts. The second data source are card metadata, which are, you can think of as being the age of the card since activation. We have some other parameters related to the high intensity financial or drug trafficking flags and the program names to which they pertain, etc. The last data source that we have access to are transactional metadata. So those are, an example of those can be transaction location, amounts, the time, and the final approval, the reason of rejection in case of non-authorization of those transactions. So now I'm going to talk about our initial methodology and the way we wanted to approach the problem from the beginning and how we altered this methodology at the end. So since we have, as I said previously in the previous slide, since we have a well-defined 4 fraud categories with their associated scenario, our initial plan was to build a multi-class classification model that can tell us with a high accuracy based on the transaction history of an account, is it a fraud or not, and if in case it is a fraud, which fraud category it pertains to. So the idea was to find the feature space that are more relevant for each fraud category and then union them and then build a very robust feature space that can give us with a high accuracy and precision once they are fed to different machine learning models, whether the accounts are fraudulent or not. However, we ran into some problems while we were working in this problem. So one of the problems was that some fraud categories are not mutually exclusive. So, for example, before making a fraud, someone can make another fraud and make it very difficult for simple features to capture this combination of frauds that are happening. Another problem that we ran into is there are some undetected frauds in the data sets, which means that this problem is of a supervised learning, in the sense that we are not sure about the negative class. For the case of the positive class, if the frauds have been detected, then we are sure these are labeled as fraud. But for the negative class, there might be still some undetected frauds in the data sets that we are not aware of. So, which makes the problem a semi-supervised in nature. So we changed our approach a little bit of the problem by trying to detect first just whether an account is fraudulent or non-fraudulent based on the history of transaction that it has. And in order to do so, we relied on 3 categories of features to be able to solve this binary problem. So the first set of features are extracted from the account's metadata. And what I mean by that are, as I said earlier, data that is related to the account, such as the account age and different historical activation flags with respect to that account. The second set of features are extracted from the account statistics, and finally, feature based on the time series. So one of the problems that we didn't want to have our feature biased with respect to the different duration of those accounts. So you can imagine that when we have accounts from different cards, all of them are not starting in the same day. We have users that have started their card history in different span periods, and so we have different lifetimes and different start dates. So in order not to be affected by this parameter, we used a sliding window approach. What I mean by sliding window is that instead of taking accounts and extracting features from different from different window of times that are different in lifetime, we took the same window size as being where we captured those accounts. So an example of what I'm saying, you can see it in the figure below. You can see we have two examples of non-fraudulent and two examples of fraudulent. The non-fraudulent one are in blue and the fraudulent one are pictured in red. So the sliding window have the same size. So you can see in the vertical axis is showing the time. You can see that those accounts are starting in different days. They have different lifetimes. However, we are taking snapshots from those accounts where they are active and where where they have the same length of the sliding window to be able to extract the same features across all those accounts in order to use them for the mining. In this case, and in this very particular problem, we used the 3 months. 3 months as being the parameter of the sliding window length of those accounts. So now I will zoom in into the different feature sets that we use. And as we discussed before, we have 3 feature sets. So the first one are accounts metadata features. So these usually are account statistics that consist of some general statistics regarding the accounts, and some of them are the address of the account owner. For example, this is a very useful scenario for drug trafficking in the sense that you can imagine that account owners that are living in a very suspicious address that is flagged with a high suspicious activity, they are more likely to do drug trafficking, for example. The age of the account owner, it's also useful. It's useful for all types of frauds, as well as the age of the account. We are more likely to suspect that a account that have been there for a long time is less likely to commit fraud. And I would like to give an example of how the age of the cardholder can affect can give us an insight whether the user will commit a fraud or not. So I plotted in the right figure, sorry, the distribution of the fraudulent versus non-fraudulent cardholders in one specific money laundering scenario from a subset of the data set. And as you can see, the users that are younger are more likely to commit this specific fraud. So you can see that there is no population that is between all the populations that are greater than 50 or 50 years old are not committing this particular type of fraud. So this is an example of a useful feature that can give us an insight, at least when combined with other features in the feature set. The second set of features that we use are account statistics features, and these consist of some statistics regarding the transactions that are taking place within that account and within that particular sliding window. And we said earlier that we use 3 months as the length of the sliding window. And some of those features involve, just as an example again, these are not a comprehensive set. So one example is the statistics regarding the transaction time of the day. Remember the scenario of the human trafficking. Maybe they all take place within, they tend to take place within a particular time of the day or a period of the day. So another example are statistics regarding the transaction amount. High transactions with high amounts, with high debit or credit amounts might tell us whether a money laundering fraud is taking place or not. Statistics regarding the uniqueness of the merchant used by the account can also be a very insightful feature regarding the money laundering case. Think about someone who is making transactions with the same exact vendor all the time. The last set of features that we tried to use in this problem are time series features. So time series, we use particularly shapelets. And what I mean by shapelets, these are sub-sequences that you can find in the time series after running a shapelet mining algorithm. And then what those shapelets are, these are subsequences that if you compute the distance between the subsequence and all the time series that you have in your data set, you might find that those subsequences have a very low distance in one class, but a high distance with another class. An example of what I'm saying is in the figure below. You can see that a good candidate shapelet in purple, if you take that shapelet and find the best alignment of that shapelet with the red class, you can see that you can almost find a perfect alignment with the purple subsequence over different places in the red class. And if you compute the Euclidean distance or any other distance from the LP norm, you will find that we have a very small, relatively a very small distance in the red class. However, if you try to do the same thing with the green class and take the candidate shapelet and run it over all and try to find the best position in the time series where you can find a almost perfect alignment, you will find that it has a very, it's not very much aligned very well, and it boils down to have a very high distance, Euclidean or any other LP norm distance. This particular set of features in this problem were not very much useful. The reason behind it is we tried this. I guess it has to do with the granularity of the data that we use. So when you're thinking about time series from this perspective, we are not sure about the granularity in which we want to go up. Should we go up until the second precision? Should we go up until the day or hour precision? We are not sure. We tried the 12 hours and the daily precisions. However, those set of mine shapelets were not showing a very high correlation with the labels that we have. So finally, I would like to talk about the final model that we used to feed the three set of features that I just discussed. So for the one who are not very much familiar with it, we use a random forest. So random forest is a very robust classifier. What it does is that it fits a number of decision trees. So decision trees are just another weak classifier that is relatively inexpensive, and it's also called decision stumps due to the low depth of the trees. So these decision trees are applied on various subsamples of the data set, and a majority voting is then used to improve the predictive accuracy of the model. And as I said earlier, the goal of this problem was to find undetected fraud within the data set. Since we are dealing with a fuzzy labeled from the negative class of the data set, which is the non-fraudulent one, we defined a incorrectly labeled or negative or false negative as being a data entry that is labeled according to our random forest model when fed with our feature space. a data point that has a high probability of pertaining to the positive class, that it was in fact the true class of that particular data point is a negative class. So if our model is telling us with a high probability, let's say more than 70%, if the random forest is sure with 70% probability that that particular data point it pertains to the positive class, even though it was the true label of that point is negative, then we say that this is an undetected fraud. And concerning the validation process, so it compares. So it consists of comparing the undetected fraud with randomly sampled accounts that are active. This has been our truly negative class, which is randomly sampled, and the undetected frauds are the ones that, according to our model, are with high probability of being fraud, but in fact labeled as non-fraud. And this is an example of this is a visualization of our feature space. So if we take the union of the three sets of features that we use for this mining problem, and we plot using a t-SNE, which is just another visualization technique. Actually, t-SNE is like PTA. It lowers the dimensionality of the high-dimensional feature space, and it plots it in 2D. So the two colors are showing the two different classes of the problem. If there is an area in the feature space that is showing a very clear color, it means that the model is doing a good job at predicting. It means that the features are doing a good job in modeling the problem and finding patterns in that particular class. But if we have overlaying colors, it means that this is the area where either the model needs to be improved, or this is the area where the undetected fraud are happening. Because remember, again, we are talking about fuzzy labels from the negative class. And before I finish, I would like you to answer the last poll question, which is, which sets of features were not very much useful for the task of classification in this very particular problem?
All right, Sukaina, thank you so much. So in order to give you a chance to look at the questions, also to give those in our audience an opportunity to submit questions to Sukaina, we're going to go back and look at the very first poll question, which is kind of a little bit of a pop quiz for us today. So the question was, which is more of a concern to the fintech business? So we had a few options here. The first one was undetected fraudulent accounts, so false negatives. The second one was continuously falsely detected fraudulent accounts, so false positives, both, or none of the above. And so 22% selected the first one, which is the false negatives, and 77% selected both. So Sukaina, what's our answer?
I think the first one was the answer, in the sense that from a business perspective, it's more important to detect a fraudulent account that we are not aware of than the fact of having some other accounts that we are thinking that are frauds, but they are in fact not. It's always good to have a list of accounts that we can manually check before making any final by a human, before making any final decision. But it's good to be comprehensive from the positive class, and have a comprehensive list of those accounts that we think are not fraud. So I would say that it's very important to for false negatives to be detected very well.
All right, we had a little canine contribution there. Sorry about that. All right. So let's get to our questions. And so the audience, it looks like only a quarter of you have voted so far. So please feel free to go in and vote on the second pop quiz poll question. And coming to the questions from the audience. So the first question is, what was the most challenging part of this project?
I think one of the different facets of this project when compared to other projects is that we needed to get familiar with the domain and data space specifics, and also the semi-supervised nature of the problem, since the negative class labels are not 100% negative, which is not a typical problem in machine learning. So I would say these are the two challenging parts of the project.
All right, perfect. And it looks like, here's another question. Which of the three data sources was the most difficult to work with, and why?
I think the time series data source is the one that is a little bit more difficult, because the other ones are just straight metadata that we can get from the account or from the account holder, or transactional metadata as a whole. So the reason why is that we were not sure about the granularity of in terms of time of the data to use. As I said, this was one of the challenging points when using shapelet mining algorithm. So I would say transactional, time series data were definitely the one to consider as challenging. And also there were some data sets that we had a lot of data, and we needed to make decisions as of which data we needed to use for the problem, what are the ones that are more relevant for this particular problem. So we had some decisions to make with regards to that as well. So definitely the time series one is the one.
All right, thank you for that. And we have a nice little comment that fraud detection is nothing to bark about. And yes, that's certainly true. This case study, Sakina, that you got to work on, or the company Data Seers, is just fantastic. And they have a wonderful case study in the September edition of Bank News. So if people are interested in learning more about Data Seers, take a peek in there. They're looking at that particular article is focused on a case study with Sutton Bank. All right, wonderful. So let's take a quick peek at your last question. So the question was, which set of features were not very useful for the task of classification? So 50% said features from accounts metadata, 10% said features extracted from account statistics, and 40% said features based on the time series. So, Sakina, we have definitely a split audience here. So what's the right answer?
I think the right answer was the feature extracted from the time series, in the sense that we used shapelets as the main mining component for those, and these didn't show a high correlation with respect to the final label. So, and as I said earlier, this might be the reason behind it is the granularity that we are not really sure about. We tried different granularities, but it didn't show any correlation. So shapelets or time series related features are the ones that were not very much helpful in this case.
All right, wonderful. All right, thank you so much. That was a great, very detailed presentation. All right, so Lorraine, I'm going to hand everything back over to you to introduce our next speakers, Lillian Vera.
Okay, so we're always pleased to welcome returning students onto the HPCC Systems intern program. Lily joined the HPCC Systems team as an intern for the third time this summer to support her PhD studies at Clemson University. And I'm also pleased to say that Lily has now joined the LexisNexis family as an employee. So I would like to welcome our LexisNexis colleagues, Lily Dew and Gus Rayner, who will demonstrate how Lily's intern project, so by latent direct allocation, how it can be used to enhance motor vehicle record analytics. So over to you, Lillian.
Thank you, Lorraine. I'm Gus Rayner. Good morning. I'm going to be talking today about how we use HPCC systems, machine learning, to map public record data descriptions into standardized categories. But before that, we have a question. We'd like to know, have you implemented a machine learning solution using HPCC systems? So if you would please vote on the poll, and we'll get the results for that later in this presentation. So I'm going to talk about the background that about public records and our mapping efforts, the approach that we've used. And then Lily's going to talk about the exploratory analysis work that she did for us this summer. And we'll talk about some of the next steps for this, this project. So public records data is data that's available from courts, there'll be birth, marriage, or death data, or licenses, contractors, or professional licenses. Also includes foreclosures and tax liens and other data as well. Businesses that use this data as part of their information technology processes have to deal with a lot of variation across states for what are very similar events. One of the things that LexisNexis offers is a set of standard categories where we've mapped the public records data onto these categories so that a business can use these standard categories and create one system that they can then use across all the states. So we use subject matter experts who have learned all the variations and are able to map this public record data to the standardized categories. And in terms of order of magnitude, the actual public record data is in the hundreds of millions of records. You remove the duplicates in each state, that reduces to millions of different text descriptions. And our subject matter experts can then need to take these millions of records and map them onto what are hundreds of categories, depending on what area they happen to be working on. So one of the challenges that we had is that the data volume was outgrowing our capacity to map, given the limited number of subject matter experts that we have. And there was a steep learning curve to map data descriptions to categories. And so in order to address this, we looked at using the HPCC systems machine learning library to generate category recommendations in mapping these public record data descriptions. This allowed us to increase our capacity because it shortened the ramp up for non-experts who map effectively and to eventually become subject matter experts. Our end goal for this is to actually have the data descriptions be mapped to the categories automatically and not just generate the recommendations. So here's a high-level depiction of this process and how it works. On the lower left side there, you see the categorized data that has already been assigned by our subject matter experts. The first two records here are about animals running at large. Our next one here is traffic-related information about running a red light. Our last category here is about licenses, specifically in the wildlife area. So the first thing that we do with the categorized data is that we clean it. We build a vocabulary. And so we'll use things like we stem the data, and there's an online stemmer that we include here that you can put in text, and it will actually give you the stems to make the words more consistent. We also get a count of all the occurrences of each word in the data. Once we've built our vocabulary, we then split our data into a training data set and a validation data set. The training data set is used to build models. And the distribution between the training and the validation data sets, usually 80% of the data is used for the training and 20% for the validation. In this example here, it's 75-25. Once you take these data that you've split, you'll take the training data and you'll build the models from that. Once the models are built, then you'll take the validation data and you'll run it through the model to see how the model categorizes the text description. In this case, the top three categories, we'll see that the first category matches what the validation data set has. In this case, the first category meaning animals running at large matches. So once we iterate through this, and it takes a considerable, this is where we spend a great deal of time here and also building the vocabulary. Lily will talk to you a bit more about some of the work that she did for that. Once we've refined our models where we can use them, then we go ahead and run new data through it. We worked through this to where there were two types of models and two algorithms that we used. One was a support vector machine, SVM. The other one's a naive Bayes to generate those three recommendations. When new data comes in, as you can see in the upper left, we run it through the models. And I've included the training data down below just to map, to show what the model was built from. The model then generates the three recommendations. As you can see there, for cats running at large, it's category 1, right, because it's a different kind of animal, it's just running at large. And for the hunting without a license, it maps it to the third category. This then goes to mappers who, if they're not subject matter experts, that can effectively map by restricting their mapping to these three categories from among the hundreds of categories that they have to map to. So this is a very high level what we did with our approach. When we first started, we actually tried to code the mapping rules directly. But we quickly found out that the complexity was such that we were effectively doing the work that the machine learning and text classification could do for us. And it turned out to be the case as we built this system. So here's again the overall process that we use, where you can see how we take the new data and run it through the model, and how we've built the models for this system. So next, I'm going to turn it over to Lily, who'll talk about some of the work that she did for exploratory analysis to help us with this effort.
All right, thank you, guys. So our exploratory analysis are using natural language processing technique. It can be known as NLP. So NLP is a very commonly and popular important machine learning technique used by all kinds of applications. You may never heard about that, but you may use it on a daily basis. For example, you may talk to your device, your Google Home. You may say, "Hey Siri," and they're gonna talk to you like a human being. So it all happened because of NLP technique. A more common example is that you're using a search engine to searching some documents or articles, and the searching terms are processed by the NLP technique and turn back to you the documents you want to search, or using a translation application to translate the text message you want to translate. A less common example is sentiment analysis. So, for example, you are tweeting a tweet, say, "I love HPCC systems," and you want to know you are happy about that or not. So the machine uses NLP technique to tell you, okay, it is a happy tweeter. You love the system. So all this NLP technique give us an idea to use the NLP technique to explore the public records to see what's the topics of these public records. Before we're really going into finding the topics of public records, we're first using the NLP toolkits on our system to force the cleansing the records. The first step is using the tokenizer tool to tokenize the records. As a result, for example, we tokenize the left-hand records into 5 terms. And the 5 terms further be analyzed by the semantic analyzer to further reverse a meaningless feature into meaningless interpretable feature. For example, here, as a result, we turn the VEH into vehicle that is more meaningful and more useful for later analysis. Based on these results, we are using the stammer tool to stemming the feature into more context form. For example, here we are transforming from the operating to upper, the vehicle to vehicle without E, this tool will help us to reduce the minor maybe typo or error in our data to process the feature. The next tool we're using in our NLP toolkit is the stop words remover. The stop words means the meaningful features, such as the, you, me, those kind of very common use of words, but they are not helpful for machine learning analysis. So we have very common use the stop words list in our system. It's also very customizable. So in our case, we use domain knowledge or domain experts like Gus to help us build the customized stop words list. So here we removed over in our terms because in over for our case doesn't help too much to do machine learning analysis. And the last step is you are transforming the finalized terms into different language model. And here we are using 2-gram language model. And after all this NLP toolkits pre-processing, we got to build the public records dictionary. And the dictionary, the documents altogether can fit into next step to using language topic model to modeling our public records and find out what is the main topics inside the public records. And here we are using latent direct late allocation topic model. It's unsupervised model that so by saying unsupervised, we mean that the algorithm don't have any previous knowledge what is right or what is the topics. They just automatically explore the public records and give us an answer what is inside the public records. Give an intuition about how LDA works. Here's one example. So on left hand, we have a document. And as a human being, we may know, okay, the green color words like genetics, species, extinct. Extinct means a topic like genetics. And the words in blue like extreme changes, climate, environmental, there means climate change. And the words in red, politicians, legislation, there may be belong to topic politics. I'm sorry. So all these will give us tuition how human beings give a categorize of the documents. But this, in our case, we have thousands of public records. How can we, without human interruption, use machine learning to get to know what is the content of tons of public records? And here, using LDA in this example, we run LDA on the documents, and it will give us the answer. The corpus have 3 topics. The topics are on the right hand. Here, for example, is climate change, and we have topic genetics, and we have politics. So as this one example, we know we can use the same logic to analyze the public records. By using LDA in our system, we analyze the public records. The LDA in our system is very helpful for us to analyze the public records because it's a very massive parallel topic modeling using the very efficient data structure to run tons of thousands of models at the same time. And also we have a very flexible hyperparameter setup model to help us set up the tons of parameters into one set. We don't have to repeatedly set up different parameters, like manually adjusting the combinations. So all these 2 features, the massive parallel modeling and a flexible hyperparameter setup, all help us to run tons of models during the project's experiments. So as a result of running LDA on our public records, we get the topics here. So you can see here, after running LDA, we can get answer what is the topics inside the public records. So here we only show the top 10 topics and as an example. For example, topic 1, we have top terms like here, operation, insurance requirements, proof, required on law. And based on these top terms and our domain knowledge, we know the public records is about lack of insurance improvement. And topic 2, the top terms are on law, speed, operation, on law, speed. And from these terms, we have domain knowledge, and we know that this public record is about on law speeding. The last example, for example, topic 10, we can see the right end is topic 10. We have top terms, motorcycle, vehicle, law, park, operation. And from the domain knowledge, we know that this public record is about motor vehicle related on law parking. So as a summary, we see LDA as a very powerful exploratory tool for us to analyze public records into very concise features as topics. And these topics can, as a concept feature, to get into different machine learning techniques to further analyze the public records. So now I'll give back to Gus to introduce the next step.
Thank you, Lily. So what's next? We want to continue the exploratory analysis that Lily is doing. That'll help us continue to get closer to our goal of having fully automated mapping of public record data. And we're very pleased that she's joining LexisNexis to work, continue the great work that she did with us this summer. The other thing is we want to refine the existing and build new models for our approach. We want to keep digging with dogs that will not be running at large. But that will involve things like taking the feedback from our mappers when they map data that is not one of the top 3 recommendations, and using that information to adjust our models. It's also things like aggregating. Right now, a lot of our models are built on a state-by-state basis because of how public record data seems to be more uniform within a state. But sometimes if you aggregate data from multiple states, we achieve better matching rates. And consistent with our desire to innovate and keep moving forward, we intend to use this machine learning approach with other business problems that we have at LexisNexis. We have one more poll question. We'd like to know, what is your machine learning expertise? If you would answer that, we'll get the result later in the talk. So, Jessica, I think we'll turn back to you with some of these questions.
All right, perfect. Thank you so much. All right, so while you guys have a moment to go and look at the questions from the audience, we are going to take a peek at your first poll question. So that question was, have you implemented a machine learning solution using HPCC systems? And it looks like 15% of you have, and 84% of you have not. So hopefully everybody will have a good opportunity to have learned something that they can implement. All right. So let's take a peek at some of the questions from the audience. All right. Here's the first question. Hi, Gus. Thank you for the great presentation. Was the ML technique more helpful than the non-ML technique for solving this use case? And can you please elaborate?
Sure. Thank you for the feedback. When we started to program the rules directly, we found that our match rates were not very high. And part of that is that the nature of these text descriptions is different from, say, reviews or blog comments, because it's very specific to the courts or the organization that generates the data. And so while it seemed simpler to us than some of the natural language processing, it was complex enough to where once we applied the machine learning technique, our match rates became higher. And so we were able to harness all the body of knowledge behind that as opposed to writing our own direct programs.
All right, perfect. So here's our next question. Where can we get these great NLP toolkits? Great explanations. Thank you. So where can we get these?
So that is a good question. Yep. I'm here. Yes, actually, the natural language processing toolkit is very accessible in our system. You can go into the attachments and links in this Tech Talk and find the link there. There is a HPCC Systems website, and from there we have a download link. You can download free models. And from there, you can find the machine learning model and different NLP toolkits there.
All right, wonderful. All right, so Gus and Lily, I'm going to give you a moment to look at some of the other questions that have come in and prioritize those for us. And while you do that, I'm going to take a quick peek at the votes from the audience for your last poll question. So the question was, what is your machine learning expertise? It looks like we're fairly evenly divided between beginner and intermediate. So 50% on each one of those, and no one answered advanced on this call, although I'm fairly certain that we've got some advanced folks out there. But again, hopefully people have learned something that they can take back. And if you have questions after this presentation, Lily and Gus both have their email addresses there. I'm sure that you can reach out to them, or you can certainly reach out to us on the Tech Talks at hpccsystems.com. All right, so coming back into the questions, here's one. How long did it take to develop the ML mapping program?
So we found out that writing the programs to create the models and that process flow that you saw was actually not the time-consuming part. It's the iterating and understanding the data and working with the models and all that exploratory analysis that Lily mentioned done early on that took the longest. So we went from start to finish in around about 8 months to where we could start to generate the recommendations for the mappers. But definitely understanding your data is where the bulk of your time is going to be spent. And for us, it's an ongoing process. We actually realize it and have put the resources in place to continue the refinement and the analysis of the data and the models.
All right, perfect. So let's take another look at the questions and some of the ones that have come in. So Gus and Lily, let's see, here's one. Did you consider other approaches for this problem besides machine learning?
Yes, I agree for this question. I think actually in the slides, Gus introduced their experience like not using machine learning, and it's kind of painful because it's really time consuming. It's not that effective, and machine learning is more good at handling the variance of the data. And based on our knowledge, the data is very it's changing fast, and the incoming data is very the difference of the incoming data of the base data is changing fast. So that's the main reason we think using machine learning is more properly for our projects, and it can handle all the incoming data in a very fast and intelligent way. Automating the whole process is important for the business and for our human interpretability. So that's the reason I think we are still using machine learning instead of other mapping tools. So I'm going to give back to Jessica.
All right, perfect. So that looks like it's the end of the questions that we have coming in here today. So more information about the HPCC Systems Intern Program. Lorraine, would you be interested in talking to us a little bit about what's available for people to learn more?
Sure. Well, I think having heard the presentations today, people can see that our interns achieve a lot in what is a relatively short period of time on some really meaty projects. So first I'd like to thank them for their hard work and congratulate them on their achievements, and to thank our mentors and colleagues who support our students during their internship. We will be opening the proposal period for the 2019 intern program probably in a few weeks' time. So if you're interested in becoming an intern, or know someone who might be, or you're an academic out there with students who might be interested, then look out for the announcements in our community forum, in our blog, and also our social media channels. I'm in the process of getting some new projects onto our available project list. So keep coming back to that list, because it's going to be updated quite a lot, I would say, in the next couple of weeks. And you can find out about the previous projects that have been done by students by going to our student wiki, wiki.hpccsystems.com, and go into the student wiki. And there's a lot of information in there about the program, how it works, and the sorts of projects that you can expect to see. If you're interested in learning more about this year's intern projects and you're attending our Community Day conference in October, it'll be a great opportunity to meet some of our interns in person, and also some of our academic partners who will be presenting posters about their work, and will be on hand to answer your questions as you look at their poster. I also mentioned at the start of this presentation about our August Tech Talk, which features some other HPCC Systems interns, and you can catch up with their presentations by listening to the recording. And you can find the link for this in our recap blog, which is written by Jessica Lawty, in the blog area of our website. And on a similar note, we have another student speaking for our next Tech Talk, which is scheduled for November 15th. So Jayashri Okanagati will be speaking, and her project focuses on significantly simplifying the code validation process for ECL development teams by allowing them to set up systems that automatically build and deploy their code when it's checked into Git. So if you're interested in hearing more about this project, don't forget to register using the details, which will be available soon in the events area of our website. And I'm sorry, Jessica, if I've stolen your thunder by mentioning that.
No, not at all. And, I have another question for you, Lorraine. What about people who might want to be mentors of our interns, similar to what Gus did? How do people participate as a mentor?
Our mentors can really be from any source. They can be somebody who is on the HPCC Systems project itself, someone within the wider LexisNexis family. We've had some of our university professors co-mentoring alongside some of our LexisNexis colleagues this year. And if we have people who are working using HPCC systems, currently thinking that they may have a project of interest to a student in some form of collaboration, and would like to mentor a student on that project, then they should just get in touch, and we can try and make that happen.
Yeah, I think that's wonderful, and it's such a great opportunity. So for people within our community who are interested in maybe working with some of this incredible young talent that's coming new to HPCC Systems, certainly they have a lot to add, but it might also be a wonderful opportunity for maybe experienced people to expand their skill set, correct? Good opportunities.
Sure. Yeah, sure. And I mean, also, if you're using HPCC Systems and you have an idea for a feature and you don't have the time available next year to mentor a student, but you have an idea, then please tell us about that idea. We can then get that idea on the list, and that might be of help not only to you but to other people in our HPCC systems community. So contribution doesn't have to mean you're a student or a mentor. You can also contribute to the program by telling us your ideas for features and enhancements.
Wonderful. Thank you so much, Lorraine. All right. So we are returning next month. We've got our HPCC Systems Summit Community Day. So hopefully everybody will be joining us for that. And starting in November, we'll be back with our regularly scheduled Tech Talks. So if you would like to submit a talk for an upcoming episode, November, December, January, we've got plenty of time here, please reach out to us, whether it's a success story or a use case or an application you'd like to demo, perhaps some sample code or tips you'd like to share. Please reach out to us at techtalks@hpccsystems.com. And you can also visit the Tech Talk Wiki for more information. There's all sorts of information on, there will be on this Tech Talk as well as our past Tech Talks. Lots of great information for you to refer to there. All right. And that's all that we have for today. So thank you all so much for joining us, and have a wonderful day. Thank you.